Hello everyone, I hope you're doing good and staying safe. Welcome to SimpliCode's YouTube channel, and in today's session we'll be discussing about common table expressions in SQL. I hope my audio is fine and the screen is clearly visible. If you guys are facing any issue, let us know in the comment section below and we will try to resolve it as soon as possible. Well, I see only a few people have joined the session, so let us just wait for another 2 minutes so that others will also join as well. In the meantime, guys, I would like to update you that we have multiple updates on various technologies on our channel. So if you are new to the channel or a tech geek who's in the pursuit of learning new technologies, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And also hit that bell icon to never miss an update from us. Well, I think most of you guys have joined the session, so let us just get started with this tutorial. Now, as you all know, working on long queries with complex logic is common for any SQL developer out there. So this can include using various joins, various levels of aggregation, data aggregations, and filtering across any number of tables. Now, in some cases, a resultant set cannot be obtained with a single query using a select statement or using a where condition. It requires a series of queries to be put together. Now, furthermore, for complex queries, the best way to write a query is to break it down into a logical steps and build it piece by piece. Now, subqueries are typically one way to consolidate functionality into a single SQL statement that can be later be incorporated back to the main query. Now, this has the potential to be useful, but it is also challenging for a beginner who has just started with a new level to read and comprehend and understand it well. So this is where, and it is possible to simplify difficult queries into a sequence of logical steps using CTE or common table expressions, which also helps to make your queries more readable and allow you to produce more complex resultant set. So in this session, we'll be discussing all about common table expressions or CTEs in SQL, how they are used, and implement them using certain examples in MySQL Workbench. So without any further ado, let's get started. So firstly, let us understand what is SQL CTE. Now CTE stands for Common Table Expressions, and in SQL it is a temporary resultant set that has a range within a single SQL statement. Now a CTE can be referenced at any place within that statement multiple times. Now generally the with clause is used to define a CTE. A common table expression do not exist as a separate statement. Instead, it is always used along with a select, insert, update or delete statement which immediately follows the CTE. So it is generally used and it enables users to write and maintain complex queries easily with increased readability and usability. So you can basically define multiple expressions within a single query. So once defined, these expressions can be referenced repeatedly throughout the rest of your queries. Now, common table expressions was relatively a new SQL feature which was lately introduced in 1999 by Microsoft SQL Server. Now, CT was first introduced in SQL Server in the year 2005, and then PostgreSQL made them available starting in 2009, and which was further used by MySQL, which has waited a bit longer and made them available in the year 2018, starting with the version of 8.0. So again, simply put it together, it is a temporary data set, guys, which returns, a query which is then used by another query. So in order to reduce the complexity of a query, we use CTE. So it is temporary because the result is not stored anywhere. So it exists only when the query is being run. So that is what CTE is all about. So let us now move ahead and let us understand why we use SQL CTE. Now the main reason is to store the result of a complex subquery for further use. Now in SQL, we will use subqueries to join the records or filter the records from a subquery, right? So whenever we refer the same data or join the same set of records using a subquery, the code maintainability will be difficult. So a CTE makes improved readability and maintenance easier for the user. And another reason being is CTE can be reusable, guys. Now, the reason why I'm telling it is reusable means, a CTE is reusable by design. Instead of having to declare the same subquery in every place you need to use it, you can simply use a CTE to define a temporary table once, then refer to it whenever you need it. So you can call upon the specified CTE whenever you want in your query. Also, CTE is more readable than a subquery. Now, another reason why we use CTE is they are more readable than subqueries. Since CTE can be reusable, you can write less code using CTE than using subquery. Also, people tend to follow the logic that we put uh, behind the CTE in an easier way than in a nested query fashion. So whenever you write a query, it is easier to break down a complex query into smaller pieces using CTE. And finally, CTE increases the performance of a query. Now, if you're working on a complex data, performance is paramount, right? So using subqueries, using multiple joins and joining various tables put together can, decrease the performance of a query. Now, CTE can be defined in various scenarios like in procedures, views, triggers, and many more. So it can be used recursively with a subquery, not which can ultimately increase the performance of a query. Alright, let us now understand how CTE works. Now, a CTE must be followed by a single select, insert, update, or a delete statement that references some or all the CTE columns. So let us now understand the syntax of common table expression. The syntax is followed as with is the keyword we use, CTE name. Now you can specify the name of your choice for the CTE as, and within the parenthesis mention the select statement with all the columns you want to get in your resultant table and from the table name, and close the parenthesis, and after that we'll be basically again selecting the columns from the CTE name instead of the table, and you can also specify the where condition as per your requirement. I hope you understood the syntax and how CTE works. Now it will be clear when we get into the execution part. So let us directly jump into MySQL Workbench for execution. Alright, as you can see, MySQL Workbench has started, and let us now run some queries using CTE. So let us just take an example for that. Let us consider the employee table for understanding how CTE works. So let me just display the values from the employees table. Alright, so the employees table has various attributes such as employee ID, first name, last name, email, phone number, hiring date, job ID, salary, manager ID, and their department ID. So let us now run a first query wherein we'll find the highest salary of an employee working in different departments, or you can say in each department. So in that case, we'll use a CTE here. And as we discussed earlier in the syntax, it starts with the with keyword, and after that you can give the CTE name as per your choice. So let us give it as highest salary, since we are finding the highest salary of employees in different departments. So highest salary, and after that use the as keyword, and within the parenthesis use the select statement and display all the records that you want to fetch in a resultant table. So select, I want my first name of the employee, last name, comma, department ID, comma, salary. Now, since we are finding the highest salary of each employee from different departments, we'll be using the rank over function. Now, we have discussed about the rank over function in our previous video, which is how to find the nth highest salary. So if you want to know it in a more detailed way, make sure you check that out. So I'm using rank over, and which is followed by the partition keyword, which is partition by. We are partitioning based on the department ID here. Order by salary. And we'll use the descending keyword here because we are only concerned with the highest salary. So it will be basically from highest to the lowest point. So close the parenthesis, and you need to give a temporary name for the rank over function. So let us just let's say give it as salary rank from employees table, right? Alright, and after that we have to mention the select statement again, where we'll display all the columns that we have mentioned in our CTE again. So let me just mention the first name, last name, salary, department ID, from. Now you have to mention the CT that you have chosen here. Now highest salary is basically the name of our CT. So I'll mention the highest salary here instead of the table name, where salary rank is equals to 1. Now why I am choosing 1 is it will segregate all the salaries and it will only choose the highest salary from that. So alright, I think we are good to go. So let us just execute the statement and we'll see the output. Alright, as you can see in a resultant set, it is displaying all the data of the employees, that is their first name, last name, and their highest salary. That is the employees working in different department and their highest salaries. So let me just explain how the query is working here. Now the CT is named here as highest salary. We use it to rank employees within each department by salary by using the window function rank over. Now we partition the data by the column which is department ID. This means we rank the salaries only within each department, not across all the table, right? So the data is sorted according to the column salaries in descending order because we want the highest salary, as I said earlier, in the department to have the highest rank, which is 1. Also, we also have selected several columns from the table employees in the same CT, and we need data from the CT in the next select statement in order to fetch in our resultant set. And in the select statement, we are basically selecting the columns needed to have in a resultant set, that is the first name, last name, salary, and department ID. So in this way, you can use the CTE to find the highest salary of each employee from different departments. Now I know you might be wondered, why CT is being used, where you can simply write a subquery to find the highest salary. Now I get it. I'll explain it in a bit where we'll discuss in the end why we are using CT here. So let us just again take another example here, guys, so that we can have a clear-cut idea on more how the CT can work. So in the second query, we'll be basically finding the average salary of each employee working in different employee. Now previously we have found the highest salary of the employee. In this case, we'll be using the finding the average salary by each department of the employee. So let us just write the query here first. So again, I'm taking with. So let us name our CT name as average salary here, since we are finding the average salary. And within the parenthesis, mention all the column names and the operation that you are performing. So since we are performing the average operation on the salary, I'm taking as average salary, as I am taking it as average salary. Just give it a alias name. And then we are mentioning the department ID from the table, that is employees, and we'll be basically grouping all the details of the employees by their department ID, so that we can have the average salary in each department. So close the parenthesis. Now again, we have to mention the select statement, which is the outer statement after the CT. Now select first name, last name, department ID, salary from employees table, right? Now basically the criteria which is to find the average salary is basically we have to join the two tables, which is basically the same table, that is employees, and we'll be comparing the salary of employees from these two tables simultaneously, right? So we have to join these two tables, that is the CTE table and the employees table here. So that is the reason I'll be joining the table now. So let me just take the employees table alias name as E, so that we can find it easily. So e dot first name, I'm taking e dot last name, e dot department ID, and e dot salary from employees E. And basically I'll be joining this with the CT, that is average salary that we have taken. Alright, so I hope you have understood this till now. So let us just give a name to this, let's say AVG, and we are joining the table based on the department ID from both these referenced tables, right? So I am taking e dot department ID is equals to AVG, which is the name of our CTE table, that is the temporary table which we have taken. So department ID, and we'll use the order by statement, so that will have a more clear resultant set. Order by department ID, and we are good to go now. So let us just execute this statement and we'll see the output. Alright, as you can see in a resultant table, it is displaying all the average salaries of the employees. So let us just quickly go through the explanation. So this query is using a CT named average salary, guys, in order to calculate the average salary in each department. Now the select statement in the CT groups the rows by department and uses the average aggregate function to calculate the average for each department. Now once we have that, we combine it with other columns from the table employees to complete the resultant answer. Now to do so, we are basically joining the employees with the CT name as we would do with any two tables to join them. So we select the columns, the required columns as we have taken here, which is the first name, last name, department and salary from the employee table, and the column average salary from the CT. So in this way, you can use the CT to find the average salary in each department of different employees. So there's a little error, guys. I forgot to mention the average salary column. So I was just wondering why we didn't had the average salary in our resultant set. So let us just mention that. Now average dot average salary, which we have taken earlier. Alright, so let us execute the statement. Alright, now you can see the salary of the employees working in different departments and also the average salary of that particular department. Now if you look at the department 10, now the salary is 44,000 and the average salary is also 44,000. Now if you look at the department ID, which is 20, now we have two different employees, Pat Frey and Michael Haston, whose salaries are different, that is 60,000 and 13,000, but the average salary in that department is 36,500. And similarly you can see for the rest of the different departments as well. So I hope this is clear. Now it brings us to the main question, that why are we using and when we are using CTE. Now traditionally you've probably noticed that CTEs are a lot like subqueries. Maybe you're wondering why I'm using CTEs when everything I did could have been done with a simple subquery. Now that's true. Aside from being more readable, CTEs have one big advantage of subqueries, that is the resultant set or the results from a CTE can be used more than once in a query. So let's say if you're working on a complex database where you have to join multiple tables from the database and you have to perform various operations. So in that case, you have to keep on writing the subqueries. Now let's say if I want to find the maximum of average salary from the employees table. So in that case, now that I've created a CTE, I can directly write a select statement which says select max, and inside that I'll be writing the average salary, which is the name of the CTE from the CTE name that is we have taken as AVG underscore salary. So now instead of calculating the average salary of each employee from different department using subqueries, which is a complete process, right? It takes a bit of time. So instead of that, I'm writing a simple CTE for that, and later I'm using the same to calculate the maximum average salary. So when I execute this, it will directly display the maximum of average salary of all the employees in different departments. So it becomes quite easier, instead of writing subqueries each and every time. Now, if the code with a subquery is less readable and it is harder to understand the code with a CT in simple way, right? So you would be trying really hard just to understand what every part of the code does when you're writing subqueries. Now, having difficulties understanding a code can be frustrating. So that is where CTEs can help you guys. It is one of the most powerful tools to process hierarchical complex data into a simple manner where you can use it multiple times. So that brings us to the end of today's session, guys. That was all about CTEs in SQL. I hope you've understood this tutorial. Thank you for watching the video, guys. If you found this tutorial informative and helpful, leave us a like and share it with your friends and colleagues. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries the earliest. Until next time, stay safe and keep coding.